Hey everyone, today let's try to solve this problem, reverse a linked list. And just to make it a bit more complicated, let's try to code out both the versions of it. One is to do it in a iterative approach and one is to do in a recursive approach. This will be helpful for interviews because most of the people can be able to solve it in an iterative way, but will face some difficulties in solve it in a recursive way. So let's just discuss the question once. So a linked list is basically reverse all the elements in the linked list, and also you can see that the pointers are also changed, i.e. now 5 has to be the head of the linked list, then 4, then 3, then 2, then 1. Okay, now let's try to figure out the algorithm. Let's try to do it in a iterative way first. Okay, so let me just write down the nodes in the linked list. 1, 2, 3, 4, 5. Okay, now let's say that we have only one element in the linked list. Okay, so in this case head, in this case this is already pointing to null, so we can just return the head. Now consider we have two elements in the linked list. Now head is this and this is the next element, right? We can use another pointer. Now at the end, how should the result look? 1 should be pointing to null. Okay, 2 is already here and 2 should become the head. So one way to do this is, let's say we can use a pointer called prev, which is always initially pointing to null. Okay, so let's just consider this. We have 1, 2, 3, 4, 5. Okay, these are the pointers. And initially P is pointing to null. Okay, now let's use a pointer current to indicate the current element and a pointer next to indicate the next element. Okay, now when we come to this state, right, we should always make cur equal to prev. Okay, so as soon as we do this, cur will be pointing here and this will go off, right? Now the current next pointer is going to be pointed to null. Okay, and as soon as we do that, right, we should make the cur as prev now. So now prev is going to become this and current is going to become this, and this is going to be done within a loop. So now how will it look next? Next will be here, cur will be here, prev will be here. So now again cur should point to next. Cur should point to prev, and as soon as we do that, this is cur is going to become prev and next is going to become cur. So this does sound pretty simple. One thing is, suppose we did it till here. So as soon as we suppose we did it till 5, how will the elements look? Elements will look like this. Alright, this will be pointing here, this will be pointing here. Okay, and now how will the current, where will current be? Current is going to be, as soon as we finish this, right, what's going to happen is we are going to make prev is equal to this, current is equal to this, and next is equal to something, right? So basically at the end we have to make sure that our loop runs. We have to make sure that our loop runs while cur is not equal to null. And as soon as we finish the loop, right, we have to set our head pointer, right? Now our head is going to be equal to prev and we can just return head. Okay, so this is a simple iterative way of how to do this. So let's just consider two elements here. Now how will it look? We're going to have cur is going to be here, prev is going to be null, next is going to be this. What are we going to do? We're going to set we're going to do cur.next is equal to prev, and as soon as we do that, we're going to make prev is equal to cur, and we're going to make next is equal to cur. We are going to make cur is equal to prev. Sorry, one second. As soon as we do this, right, now what's going to happen is prev is going to become here, cur is going to become here, and next is going to be here. So again we're going to do this process. Now again cur.next is going to be equal to cur.next is going to be equal to prev. Okay, and as soon as we do that, prev is going to be cur, cur is going to be next. Okay, and now we see that as soon as we come here, right, its cur is going to be null, so we're going to exit the loop. Okay, I think this should be pretty clear. Let's just code it out once quickly. So as we said, we're going to make the use of 3 extra pointers. Cur, which is going to be initially equal to head. Prev, which is going to be equal to null. Okay, and we have to make the use of a next pointer as well. But since next will be only used within the loop, we can write it inside the while loop. So we're going to do this while till cur is not equal to null. Okay, and as soon as we do this, what are we going to do? We're first going to initialize next, which is also a list node. And next is going to be equal to cur.next. Okay, and as soon as we do this, what are we going to do? We're going to make cur.next point to prev, right? And as soon as we do this, we have to shift our pointers. Now what is going to be prev? Prev is going to be cur, and what is going to be cur? Cur is going to be next. Okay, I think all this till here should be clear. And at the end, we are going to come to this point. Now we have to set head. Head is going to be equal to prev. And as soon as we finish that, we're going to return head. Let's just test this out. Okay, looks like 3 of the test cases passed. Let's just add one more test case where there's just a single element. Okay, looks like it seems fine. Just see if it gets accepted. Yep, it seems fine. Okay, so this was the iterative approach. Now let's try to do it recursively. Okay, so doing it recursively can be a bit challenging. So let's take the same example. 1, 2, 3, 4, 5. Okay. Now recursively, let's try to reverse the array. Now let's say there's no element in the array, then we just have to return head, because head is going to be pointing to null. If there is just one element, if head.next is equal to null, again we have to return head itself, because this is only the reverse of the element. Now consider there are going to be 2 elements like this, right? And we have to reverse the head, which is 1 head. Okay, now this head is going to be 1. Now we know that if head is equal to null, and if head.next is equal to null, we can just return head, right? That's what we saw here. If it's null, or if there's just one element, we can return this itself. Now suppose there's 2 elements like this, we have to recursively try to reverse the array. So let's just call a function. Let's just recursively call the function again to reverse the next element. Okay, so now we're just going to call the function. So initially rev is going to be 1. We're going to call p is equal to rev of 2. Okay, now if you see rev of 2, right, head dot next, so this is now the head, right? 2 is now the head. This dot next is going to be equal to null, so here we're going to return 2. Okay, so now head is going to be pointed here, and let's p, the return value, is going to be pointed here. Now what we can do is, we know that the so if we see it if we just consider this, right, we know that the next of this element should be pointed back to head. So what we can do is head dot next, which is 2, and 2's next should be pointed back to head, right? So in this case, if we do this, now 2 will be pointed back to head. So let's just write that down. Head dot next should be equal to head. Okay, I hope this makes sense. And now another thing which we should do is, we should make head, which is currently 2, head dot next should be pointed to null, right? And now the reverse of this linked list, it's going to start with p, right? So at the end we should just return p. Okay, I hope this is a bit clear. Now let's try to do a dry run for a bit longer, for a linked list longer than 2 elements. Okay, so in this case, what are we going to do? We're going to call rev of 1, head of the linked list, right? And now what's it going to do? This dot next, this is not the head, which is 1, is not equal to null, and 1 dot next, which is 2, is not equal to null. So now what's going to happen is p is going to be equal to rev of 2, right? And again 2 is not equal to null and 2 dot next is not equal to null. So again we're going to call p is equal to rev of 3. Okay, now when we come to rev of 3, right, we can see that 3 dot next is equal to null. So in this case we're going to return 3 itself. So in this case 2 when the head is 2 and when the head is 2, p is going to be equal to 3. Okay, so now what we're going to do, head dot next we're going to make it head. Okay, so we reverse this one part. And now just to prevent the like we saw in the case of 2 elements, right, we have to make head dot next is equal to null. So now let's do that. Head dot next is going to be equal to null. So now it's going to look a bit like this. Null, and we're going to return 3. So here p is going to return 3 to null. Okay, and now we have head is going to be equal to this. Now again we're going to do the same. Again we're going to follow this function where we're going to make head dot next, which is 2, dot next is equal to 1. So now we can see that this is going to be erased. We made it like this, and now we are going to make head dot next is equal to null, and we are going to return 3. And hence we see that we have reversed the linked list in a recursive fashion. Okay, so let's try to code this out. Let's remove all this. Okay, and now let's try to code it out right here itself. We saw that if head is equal to null, or if head dot next is equal to null, we're just going to return head itself. And that's basically in the case of a null linked list, a linked list with size 0. So in this case, we're just going to return the same element. And here, if the linked list is of size 1, then also we can just, the reverse of 1 is just going to be 1, right? So this should make sense. Now, let's have list node p is equal to, we're just going to we're going to recursively call the function again, where we're going to find the reverse of the next element. Okay, and this will continue recursively happen till we reach the end of the linked list, right? And if we reach the end, it's just going to return the last element. If we release a second last, then what we're going to do is we're going to change the order of the pointers. Head dot next we're going to be equal to head. Okay, and that's in the case of this. I hope this is understandable, right? In 1, 2. Okay, now we're going to call rev of this, and now we're going to call rev of 2, and this is going to return p is equal to 2. Now head dot next is 2, and we are changing that pointer back to head. Okay, and now we have to make head dot next is equal to null. head.next is equal to null. And after we do this, right, we have to return p, which will be the reverse of whatever we did till now. Okay, let's just try to run it out. Hopefully we won't get any errors. Okay, looks fine. Let's try to submit it. Okay, and now let's try to look at the space and time complexity for both the approaches, right? In the iterative way, what were we doing? We were using some variables to iteratively reverse the linked list, and we are going to traverse through every element only once. So the time complexity in the iterative approach, right, the time complexity will be O of n. Okay, and the space complexity is going to be O of 1, since we are just using some variables to reverse the linked list. In the case of the recursive approach, right, here also we were traversing through all the elements only once. So the time complexity is O of n, and the space complexity, however, is going to be O of n, since we were using essentially when we are using a recursive approach, right, every element is going to be stored within a stack. So the storage internally is going to be O of n. So I hope this is understandable. That's it for today. Thanks everyone for tuning in. Bye bye.